Hello. In this video, I will continue to work on trigonometric equations and how to solve them. We are trying to solve trigonometric equations. And in this video, we are going to specifically work on solving trigonometric equations that involve multiple angles. Not only theta, but they can have 2 theta, 3 theta, maybe theta over 2, okay? But the idea is simple. We are going to, as it is summarized here, we are going to solve. For example, if it is 2 theta, we are going to solve the equation for 2 theta, or maybe 3 theta, or maybe theta over 2. Then, after doing that, after finding the solutions for example, 2 theta, we need to just solve that solution, use that solution to solve what the theta is, right? Okay. All right, let's move to the examples. Cosine theta is equal to root 3 over 2 over the interval. So solve this over the interval from 0 to 2 pi. Okay. So cosine 2 theta is equal to root 3 over 2. Again, root 3 over 2 is a special triangle, right? It is 30, 60, right? 30, 60, 90 triangle. 1 root 3, 2. So, but this time we should write the general solution, okay? So 2 theta is equal to 30 degrees plus 360n. You remember that, right? 360n or 2 pi n. Maybe I can write that way. It doesn't really matter, but or I got the first angle in degrees, right? Maybe I can write this way. Okay, 360n. And so, what other angle gives the same cosine? And to find that, just find the symmetry of this point, right, through the x-axis. You remember that fact, right? And this is third as well. This is -1, this is 2, this is root 3, but again cosine will be adjacent over opposite, so it will be root 3 over 2. But which angle is that? So I have to go this way again, right, as I do always. So it is 360 minus 30. So the second set of solutions is coming from 330 plus 360n. Okay, all right. So, but remember, we need to solve these equations for theta, right? Not 2 theta, not for 2 theta. So let's solve these 2 equations for theta. And how can I do that? Let's divide both sides by 2. Okay. So for example, from here I get theta is equal to, divide everything with 2, 15 degrees plus 180n. And from there I get theta is equal to, if you divide 330 by 2, it will be 165 degrees plus 180n. And normally, as you remember from the previous videos, we have infinite many solutions, right? And these representations are for the infinitely many solutions. But the question is specifically asking the solutions between 0 to 2 pi, right? Or 0 to 360 degrees. So how can we find those solutions? We can just plug it in a couple n values, as long as we are fitting in this interval, okay? If we are exceeding this interval from up or from downside, then those angles are not counted, okay? So for example, first of all, I can take n is equal to 0, right? If I take n is equal to 0, what I get from the first guy, theta is equal to 15, which is in this interval, right? And from the second equation, I get theta is equal to 165. Again, which is in this interval again. For n is equal to 1, what do we get? Theta is equal to 15 plus 180, which is 195. Nice, because again, it's in this interval. What about the bottom guy? For n is equal to 1, I get 180. 165 plus 180 makes 245. No, 345. Which is nice enough again because we are still falling into this interval, right? For n is equal to 2, what do we get? Theta is equal to, actually when n is equal to 2, right, it will be 2 times 180, it will be 360, and plus something will be anyway bigger than 360. So the solutions coming from n is equal to 2 case is not falling. You see that, right? Into our interval. By the way, I can also plug it in negative values. For example, I can say n is equal to -1, but in that cases, theta will be a negative angle. But again, our interval will be between 0 and 2 pi. So all the solutions are coming from n is equal to 0 and n is equal to 1. And these are the solutions, okay? All right, I hope it's clear for everyone. Let's move. Let's look at the next example. Cosecant, okay, 8√3 cosecant 2 theta plus 16 is equal to 0. Again, let's solve this equation for cosecant 2 theta. Cosecant 2 theta equals, actually, maybe I can first write 8√3 and subtract 16 from both sides, -16, and divide both sides with 8√3. I get cosecant 2 theta is equal to -16 over 8√3. And if I simplify that, 1 and 2, right? -2 over √3. So cosecant 2 theta is -2 over √3. Then what is sine 2 theta? Just flip, right? Just flip this, guys. -√3 over 2. Okay. Sine 2 theta is -√3 over 2. And again, this is a spatial triangle, right? So what is that triangle? Let's try to draw the picture of it. Sine should be -√3 over 2, right? So first of all, it should be in the third and fourth quadrant because where these quadrants are where the sign is negative, right? And I have to use this triangle, right? 60, 30. And this is -√3 because this is the negative y-axis, right? And this is again -1 because negative x-axis, and this is 2. Okay. So from there I get 2 theta is equal to, of course, which angle is that? Not the angle is not 60, right? I have to start from the x-axis and come all the way down here, and which makes 180 plus 60, 240 plus 360n, or 2 pi n to n pi. And as always, now we can get another solution, right? So and remember, sine is the y value, right? That's why to get the same y value, I need to take the symmetry through the y-axis. Okay. Okay, of course, since this is symmetric, this angle is also 60. This is 1. This is again 2, right? And this is -√3. Okay. Or maybe I can write this way. Yes, this is 1, this is -√3. Okay. This guy has also a sign -√3 over 2. But which angle is that? Again, I have to start from the x-axis and come all the way down here. So 360 minus 60. This part is 60, right? The whole angle is 360. So 360 minus 60 is 300. So sine 2 theta, actually, so this is the first solution. And the second set of solution is 2 theta is equal to 330 plus 360n. And again, these solutions are for 2 theta, right? So I have to solve these equations for theta. Do I have enough space for that? Okay. So from there I get theta is equal to divide again both sides with 2, 120 plus 180, and of course bunlar degrees. These are degrees. And from there I get theta is equal to, if you divide both sides with 2, 165 degrees plus 180 n. Okay. But again, what are the solutions? How can we get the solutions? Just plug in a couple n values, and as long as you are fitting in that given interval here, we are good to go, okay? For example, if I plug it in n is equal to 0, what do I get? Maybe I can write down where? Maybe here. If I plug it in n is equal to 0, I get theta is equal to 120, which is in the interval, and theta is equal to 165. And when n is equal to 1, I get 120 plus 180, which is 300. Nice, because it's in that interval. And from there, I get 165 plus 180, which makes 345, right? No? Yes, 345. 345, which is nice again because I am still falling in this interval. But if you plug it in n is equal to 2, again, we will get a bigger angle, which is not in our domain. And when n is equal to -1, for example, again, this is less than 0. So these are the only theta values which satisfy our equation, all right? All right, let's move to the next example. Cotangent theta equals -√3 over the interval 0 to 2 pi. Okay, cotangent is -√3. Which angle is, where is cotangent negative? Which quadrant cotangent is negative? It's in second and fourth quadrant, right? So let's try to draw the picture of it. And this is also a spatial triangle, right? Let's try to be careful. And cotangent is adjacent over hypotenuse. So adjacent should be -√3. Then this angle should be this way, right? This will be -√3. And this should be 1. And this is, which angle is that? This is 30, right? This is 60. This is 90. Okay, nice. So this angle gives the cotangent is equal to -√3, right? Cotangent is, again, remember, adjacent or opposite. That's why we got -√3. So which angle is that? Again, we have to look at, start from x-axis and come here. So it is 180 minus 30. It is 150, right? So theta is equal to 150 degrees. And remember that the period for cotangent and tangent is pi, right? That's why I can say, just say plus n pi, okay? And the good thing for cotangent and tangent is, as long as you get one angle, that's enough. I mean, as long as you get one angle between 0 and 2 pi, that's enough, because since the period is pi, you can get the other angle between 0 to 2 pi by just using the general solution formula, okay? And okay, as we did in the previous examples, we can plug it in couple n values, right? If you plug in n is equal to 0, we get theta is equal to 150. Cool. It's in this interval, which is nice. When I plug n is equal to 1, 180 plus pi, and pi is 180, right? 150 plus 180 is 330 degrees. Nice enough, because again, it's in our interval. But if I plug it in a bigger n value, right? For example, n is equal to 2, it will be bigger than 360, so I cannot take it. And if I plug it in -1 for n, it will be a negative angle. So we get only 2 solutions, and these are the solutions, okay? All right. Let's move to the next one. Tangent 2 theta is equal to -1. And again, which quadrant is that? Tangent is negative in the second and in the fourth quadrant, right? So, and this is again a special triangle as always. And we all remember that this angle is 45, right? 45, 45, 90. And this is -1 because negative x-axis. This is 1 and this is √2. So tangent is opposite over adjacent, which is -1. Cool. But as always, now this our angle is not 45, but this part, right? This is our angle, which is 180 minus 45. So 135. So 2 theta is equal to 135 plus n pi. Or maybe I can write the pi in terms of degrees, which is 180, right? So 180 n. Okay. But this is for 2 theta, right? But I have to solve for theta. That's why let's divide both sides with theta. Theta is equal to 135, not 135. 135 degrees over 2 plus 90 n. And 135 degrees over 2 is 67.5, right? 67.5 degrees plus 90 n. And again, we can just plug in a couple n values and try to see whether we are falling in our interval. For n is equal to 1, what do we get? 67.5 plus 90. Let's start with n is equal to 0, of course. 67.5, cool. This is in our interval. When n is equal to 1, 67.5 plus 90, which makes, if it was 70, 90 plus 7 is 160, but 157.5. Okay, cool enough, because it's still in our interval, right? When n is equal to 2, 67.5 plus 180, which makes 247.5, right? Cool again, because we are still in our interval. What is next? When n is equal to 3, this for n is equal to 2. When n is equal to 3, it will be 67.5 plus 270. And 270 plus 67.5 is 337.5. Cool again, because we are still in our interval, right? It's still between 0 and 360. But if I plug it, n is equal to 4, 90 plus 4 will be already 360, right? So the angle will be bigger than 360. So these are the all angles in our interval. Okay. All right. This is all for this video. In the next video, I will be working on different types of equations. All right. So for this video, let me stop here. I will see you in the next video.